Hello there. Today we'll be doing top K frequent words. Let's see how this is done. So let's start with understanding. Let's try to understand the problem. Let's see what's going on. So here we have a list of words, and we are looking for the words that have the top two most frequent of the words, which is I love. And you can see this because I love appears twice, and leak code appears once, and coding appears once. And that's why we have this particular output. And so this is our happy case. Let's check that out. So happy case. So usually we're given a couple happy cases, and now we have to think of our own edge cases. So what are some ways that we can think of an edge case? Like what if there is no input? Like there is no input. There are no words. And what do we return? I think that is, well, the answer to that is, first constraint, there must be one word at least. So our edge case is going to be one word. And what if the word length is below 0? Well, we're not going to look at the word length below 0 because there's at least one character. Also, K is between 1 and the number of unique words. So there's no way you can go out of bounds with K. So the problem is restricted to be within bounds, so all inputs will be proper. So we don't have to handle any edge cases here. Okay, with that, we are really happy with this understanding. And time complexity, I'm believing it's going to take O of n log k. So if we use a heap, we can get this in O of n log k because we can store everything in a counter, and then that'll take O of n, and then we pop everything into a heap, and then we pop everything out as the most frequent number, and that will take log k times. So that's our fastest way of doing this. Of course, we can use a priority queue, which we're expected to do because we're doing a priority section. And with priority queue, we're going to take, I believe, n log n time because we do have to, because we're not organizing in terms of a heap, we're organizing in terms of a priority queue, which is basically an array, and that takes n log n to sort. Well, with that, we are doing a space of O of n because we're storing everything. So that's all. And let's go on to our, let's say, a match. We can do either a queue, which we are going to do, priority queue, or a heap. We can find the difference between the two. So let's plan. So the plan is get the frequency of each word, place into a heap or priority queue, and get k items for results. Then return the results. Perfect. Let's do it. So let's implement and go for it. So first things first, let's get the frequency. And how we do that is we're going to use a counter. That's the fastest way to do this, and we put words in there. So what this does is that it gets the word and count. So right. So let's print out something. Let's for word count in frequency dot items. Let's get print word. Make sure I'm doing this properly. Let's do some prints. I'm gonna just return. It's gonna be false, but let's print something. See if I'm doing this properly, and let's see what's going on. So as I saw, it's we're printing the words and the counts, as you can see, and so that means we're ready to make a heap or a priority queue. In our case, we're gonna do a priority queue because that will take the most frequent item and put it into the first item that we'll remove. So to get a priority queue, so priority queue equals, how do I make one? I think like something like that, maybe. Let's go and find out how to do this. and Python, please. And hopefully I am. Looks like it's a queue.priority queue thing. All right. Oh, never mind. My bad. It uses a heap. I was wrong. Okay. Well, we have to do a from queue import to get this, and let's get that going then. Okay, so we grabbed it, and how do we use it again? Let's check it out. So we have to put. So we have to use the put option, and we're gonna do that. So priority queue dot put. We're gonna put in a tuple of the negative count because we're gonna push out the smallest item first, and we're gonna throw in the word. With that, we are ready to make our k items in k, range k. So we have to have a results in an array, and let's results dot append. Let's append that word. So what is the word? Well, the word and the count is going to be equal to priority queue, and I think it's like push maybe. It's dot get. Okay, so we got the next item. Next item is going to be count in words, and then we'll just append the word, and we'll return the results now. So let's run it. Okay, perfect. I think we got the answer, and it should work out pretty well. Let's do a review and review our problems. I mean, our happy cases. I think our happy cases are inside our test case, as you can see here. And we have done both test cases, and we are good. We are good to go. So let's submit and go from there. So evaluation. The evaluation is exactly as we predicted. The prediction is going to be O of n log n, or k now at this point, because it is using a heap for some reason. And the space is O of n. Because we are using the space of a heap. So let's try it in the heaps and see what happens, right? So we comment this priority queue out. Let's try heap. So heap is equal to a, so it's for word and count in frequency items. And we're going to take the negative count and the word for this item. We're going to heapify it. Heap q dot heapify heap. Very good. With that, we don't need this line of code, of course, and we just do a heap pop instead. Heap q dot heap pop, and we append the word. We should run this. Okay, we have an issue. Takes one argument. We forgot to pop the heap. My bad. And we are good to go. With the heap, I believe that we should get a quicker answer. Oh, it's the same. Well, we learned something new today. And that is the heap and the priority queue is the same. Well, with that, I hope you learned something today. If you enjoyed today's video, please like and subscribe. If you want more videos, check the link in the description below. Thank you very much, and I'll see you in the next one.